All right, let's talk a little bit about testing. So here I have a population of people, and I have colored them as green and blue to indicate whether or not they have had COVID-19 in green or whether they have not in blue. So let's sort them out so that it's a little bit easier to see the prevalence. Okay, so here on the left, I've got my group of people who have had COVID-19. On the right, I have the group of people who have not. And so the prevalence in this population is 50%. 50% of the people in this population have had COVID-19. And let's say I come out with an antibody test and I want to be able to test who has COVID-19, who has had it in the past and who has not yet. And so I'm going to apply this test to the whole population. So here I'm assuming that everybody got the test. And let's see what the results are. So this portion of my COVID-19 folks tested positive. So I'm denoting that in green here in this box. So I've got these 40 people tested positive. And these 10 people here, they tested negative. And so the sensitivity of a test is defined as the percent of people who tested positive given they had COVID-19. And so in this case, if I look at my 50 people with COVID-19, 40 of them tested positive, and so my sensitivity is 80%. And looking at the results for my non-COVID patients, I had 40 of them that tested negative, 10 that tested positive. And so the specificity is the percent of people who tested negative given that they did not have COVID-19. And so my sensitivity of this test is 80%. So the sensitivity and specificity, those are test specific. Those are basically defined prior to giving the test. You can know kind of how sensitive or specific it is in the given population. But unfortunately, just those numbers alone, they don't tell me how likely I am to have had COVID-19 given I tested positive. We're going to need something slightly different for that. So going back to the full population, if I just look at the people who tested positive, I can calculate the probability of having had COVID-19 given I tested positive. And so in this case, it's going to be 80%. I've got just 10 out of the 50 who had not had COVID-19 who tested positive, given this sensitivity and specificity. So let's change up the scenario just slightly. In my original scenario, I had a 50-50 split of those who did and did not have COVID-19. And let's change it now to be just 10% of my population had COVID-19. From some preliminary numbers, that looks like maybe a little bit closer to the reality. And so let's organize those just so we can get a better sense. So we've got 10 here that have had COVID-19. We've got 90 that have not had it. I'm applying the same test here, and so I'm going to end up with the same sensitivity and specificity. And so among those who have had COVID-19, I've got 80% that test positive. That's because I have 80% sensitivity. And among those who do not have COVID-19, I've got 80% that test negative because I have 80% specificity. So I'm still applying that same test. I end up with the same sensitivity and specificity. But my prevalence here is different. My prevalence in this population is 10%. And so now if I look at just those who tested positive, now the probability that you had COVID-19 given you tested positive is only 31%. So this is really important to remember when we're thinking about testing, that the prevalence of the disease, your probability of having the disease, is really important to factor in, not just the sensitivity and specificity of the test. And so if it was pretty unlikely that you had COVID-19, it's going to be pretty unlikely that you had it even if you test positive. Now, as you know, this is more prevalent in populations. Of course, this number is going to increase because as it becomes more likely that you actually had COVID-19 because it's spreading through the population, then that number will rise up. Similar to like we saw when 50% of the population had it in our original example, then the probability of having it given you tested positive went all the way up to 80%.